how to find, I would ask Sharat to respond to this, how to find the ideal number of clusters in a data set, both in agglomerative and in k-means.
Yes, thank you, Nitin, for that question. Well, it is very subjective again. There will be a very, I should say, strong inclination towards the business requirements on how many clusters we need to choose on the given data set. But saying that, the algorithms have different approaches. These are designed, they are developed in different ways. Agglomerative clustering will allow us to take a subjective decision after we complete the hierarchy creation. That is, once the hierarchical clustering, which is agglomerative clustering predominantly, is done, we will be able to visualize the entire process using something called as a dendrogram, a visualization, a tree-like diagram. Using that, we will be able to take the decision. But again, this is more from a manual interpretation. The same way for k-means clustering, we basically look into something called as tree plot or elbow curve, which I was explaining in the last session, which tries to capture the inertia score, which is nothing but the homogeneity within the cluster. For different number of clusters, we'll try to identify how much homogeneity is something that we are able to obtain. Higher the homogeneity for a given cluster, better the cluster number. But at the same time, we also have automation function that can be used, which is called as cluster eval. Right? This is an algorithm which will allow the clustering techniques to automatically be evaluation is performed, tested, validated, you can say. And to do that, there are different parameters which the evaluation technique can take. The default one is the sill-out technique, which is very popularly used, which ranges again from -1 to +1, but we consider the magnitude from 0 to 1. Stronger the magnitude, better the clustering exercise. Anything below 0 is very bad clusters. I mean, it is completely opposite from right, our objective. So that's the another function that we can use. It's called as clustevolve. You can always go back and check the repository pypi.org for this package, and it has very comprehensive documentation which can help you to understand how automatically we can try and do the clustering, which also identifies the best number of clusters. Yeah.
All right. Thank you, Sharat. I think there's a follow-up question. We'll quickly address the question. Okay. My guess is on the basis of the questions that we are receiving, benefits and limitations of hierarchical and k-means clustering. Another person has asked what shallow means. I'm assuming that some of you have not completed your training, which is perfectly all right, and it's really commendable that you are trying to get into the advanced topics. Good, well done. So all these things would become clear with our training programs that we offer at 360 DigitMG. We have a plethora of training programs. If you are not a student, you can definitely try and get some more knowledge or get the information with our career guidance counselor, or watch our YouTube channel 360 DigitMG, wherein we have put in a lot of free content about these things. All right. Now, but nevertheless, having asked the question, I'll quickly respond to that. So, like I said, it depends on the approach. Everything has its own pluses and minuses. If there was something that was not good, we would have discarded it long back. All right. We don't use, the cathode ray tube monitors because it is not good. Simple. So on that logic, everything has certain advantages. So for smaller data sets wherein it is the visualization, you want to have a more interactive experience when you're doing the clustering process, you go for the hierarchical method. You know what is happening. You're able to see which data points are going there. You may decide to, even after that, manually say, no, you know what, while the hierarchy says it should be like this particular data point, I prefer there. 25, 30, 40, 50, 100 maybe data points which you can view. is one thing. That is the advantage you have, which means if it is 500,000, 2,000, 20,000 records, you cannot even look at the hierarchy, and therefore the decision-making process cannot be done. So that is a disadvantage. So while the same thing is an advantage, it is also a disadvantage when you want to go for a bigger number. K-means clustering is more kind of, I would say, impersonal, and it's more suited for large data sets. It is relatively faster. All right, but then you really don't get the personal interaction. Where do you want to see the data points, how they are traveling, etc. So that's the benefits and limitations of both hierarchical and k-means. Shallow machine learnings are machine learning that has very little. Shallow is shallow water, deep water. So when you say deep learning, it goes into the depths, tries to learn more and more, tries to understand deeper into this thing, ask more questions. What if, what next kind of a things. And shallow machine learning is just understands very fundamental aspects of the data set and then tries to give the result, which may or may not be very good, or may not be able to reproduce it for the production data. So that is a shallow machine learning. Really interesting. We are having a lot of questions flowing in. So I think, yeah, Bharani, could you please answer the question?
What is the question, Nitin?
One minute.
Ideal number of clusters is
Ideal
something.
number. Yeah, that was already answered. Somebody has repeated the question. Okay, my bad. My bad. I thought it was just jumping in, so that's already been answered. Thank you. Yeah.
But just to tell, we have elbow curve or spree plot. There is something called as gap statistic. And we have silhouette method. All these are used to determine the number of clusters. Yeah, but a number of clusters also depends on the domain knowledge, right? You need to interact with the customers. You need to interact and understand what business they are into and how many clusters really make sense for them. It's not something which is decided by us only based on statistics, but you also consider the domain aspect and then decide how many clusters actually make sense. Yeah.
All right. So moving along again in clustering, okay. We are talking about the hyperparameters that are there. So apart from K, which we choose to improve the clustering, we choose. I mean, that's something that we have discussed. Apart from that, where we choose the elbow curve may give you a K value, let us say 6. So we try maybe 4, 5, 6, 7, 8, and choose the best. Apart from that, are there any other things that we can tweak around in clustering? Question to Bharani, please.
Okay. Yeah, absolutely, Nitin. So I would take example of probably hierarchical clustering, and try to help people understand a few things about that. When it comes to hierarchical clustering, we have different libraries using which you can accomplish hierarchical clustering. One is your SciPy, and another is scikit-learn or sklearn. Sklearn is something which people use extensively for any machine learning algorithm to be built. In this, we have a lot of hyperparameters. Hyperparameters are those options which can be changed so that you can experiment your algorithm with different options. For example, number of clusters. You can say number of clusters is 2 or 3 or 4 or 5 or 6, whatever. Of course, you may get started with minimum 2 clusters, and the maximum number of clusters possible is equal to the number of data points. That means every individual customer would be treated as one different cluster. At the bare minimum, you should have at least 2 clusters, right? Otherwise, it doesn't make sense. You are not doing any clustering. If you say that entire group of customers belong to one segment, if you're making such a statement, then there is no clustering there. So number of clusters is one hyperparameter. Then we have something called as affinity. Affinity means distance. How do you calculate the distance? And K-means clustering or hierarchical clustering or majority of your clustering techniques majorly depend on distance in order to perform the underlying logic. We have Euclidean distance, which is also called as L2 norm. Then we have Manhattan distance, which is also called as L1 norm. Then we have Mahalanobis distance. We have cosine-based distance, and you have a lot of other distance measures. So we as data scientists have to experiment with different, distance measures and then figure out which one is better.